Okay, so in the same way that we can apply certain rules to equations, we can do that for equations in terms of logs. So in the same way that perhaps we'd square root both sides or square both sides, divide both sides by 2, then we can basically get rid of the logs on both sides as long as it's in the most simple position to do that. So for example, in this first question, we've got log of base 5 of x plus log of base 5 of 3 equals log of base 5 of 21. Right, we can't just divide through by the log of base 5s, but if we can get it to such a point whereby we have just one log of base 5 on each side, then we can basically take the anti-log of each side, okay? So we can apply the rules to the left-hand side, in which case we can simplify that to log of base 5 of 3x. So therefore, if the log of base 5 of 3x is equal to log of base 5 of 21, then 3x must equal 21. And from there, it's nice and straightforward. X would just equal 7. Similarly, with the second example, okay, if we've got the log of base 8 of x plus 1 plus the log of base 8 of x minus 1 equals to log of base 8 of 15, if we can simplify the left-hand side first of all by just using the rules and multiplying these two together, then as they're the same base, and that's important, we can just take the anti-log of both sides. And you don't need to write anything for that. You just literally need to write that x plus 1 times by x minus 1 must equal 15. And then it's just a case of solving a quadratic. Multiply it out, move the 15 over, simplify it as much as you possibly can. From here, ideally, you'd probably go and find the difference of two squares to give you the two answers, but there's nothing wrong with just saying x squared equals 16 as long as you remember that when we find the square root of 16, we have two answers, plus and minus 4, okay? As it happens for the question, because x has to be greater than 0, and if we're trying to find the log of something, it does need to be a positive number. We can get rid of the negative one, but you do have to have mentioned this first and then actually neglect one of the answers and just write the answer as x equal to 4. Okay, you need to make that clear in your final answer. What you might do is do the square root of 16 and just say 4, and yes, that is the answer, but according to the equation that we've been trying to solve, there are two possible solutions, but in the circumstance, in the situation that the question starts, there is only one solution. So we need to make it clear when we're solving this equation that there are two solutions, but when we're solving the actual logarithmic equation in the start, there's only the one solution, okay? So then in a similar way, we might have situations like these two, whereby we have either a constant on one side, or we have a log with a different base. And if there's a log with a different base, then you can't do the anti-log, you can't get rid of the logs in the same way that we did the previous examples. And obviously if there's a constant, it's very similar. So you have to take a slightly different approach. So the first one here, okay, we can still apply the laws to the left-hand side because the bases are the same, but from here, there's not a log on the right-hand side. So our only option at this point is to rearrange it into an exponential form and say that x over 5 must equal 3 squared. And from here, x equals 5 times 3 squared, which is 45, okay? For this other one, we have no option apart from basically simplifying the log of base 4 of 16 into a constant. So you're almost going to get to a point where you see something like a log of base 4 of 16 and know, obviously, that you can do something in terms of the 16, in terms of writing it in terms of 4. So it would be log of base 4 of 4 squared. The left-hand side simplifies as before, but on the right-hand side, what we're basically trying to do is get rid of that log altogether. There's nothing we can do to combine the two logs on both sides because they have a different base. Okay, so if I can rewrite log of base 4 as log of base 4 of 16 as log of base 4 of 4 squared, then obviously it just simplifies to a 2. And once it just simplifies to a 2, I can apply what I did in the first question and write it in exponential form. X minus 1 times by x plus 2 must be equal to 2 to the power of 2. And then it's just back to that previous example, moving everything to the left-hand side after we've multiplied out the brackets and then factorizing it to solve it. In which case we get two answers again, but this is the solution to this equation here. We're trying to find the solution to the initial example, and it says in the question, it won't always do this, but it says in the question that x has to be greater than 1. Again, we want to find the log of a positive number, in which case it can't equal a 0 or anything less. So the possibility of x equal to minus 2 doesn't, x equal to minus 3 doesn't work, in which case our only answer is x equal to 2.